So first, what we need to do, we need to see if beta hat is an unbiased estimator, and we will say beta hat is an unbiased estimator of beta provided expectation of beta hat is equal to beta. Now what is beta hat? You know beta hat is equal to summation of small xi yi divided by summation of small xi square. And this can be rewritten as summation of ki into yi. This part we have already done in earlier classes. And again, it can be rewritten as beta plus summation of ki into ui. As we discussed, that beta hat is equal to summation of small xi yi divided by summation of small xi square. So what basically we need to do? We need to replace this small yi with capital yi minus y bar. Then through mathematical simplification, what we are getting, summation of small xi into capital yi divided by summation of small xi square minus y bar into this, and you know that summation of small xi is equal to 0. So this part would be cancelled out. So we will be having this, and we are denoting small xi by summation of small xi square as ki. So essentially we are getting this. And again we are replacing capital yi with alpha plus beta xi plus ui. Now here essentially what we are saying, beta hat is a linear function of y. And then through subsequent derivations we are getting, yes.
Sir, how did we replace like sigma xi yi by sigma xi square by sigma ki yi? Like, because they are like in numerator and in denominator, like they are sigmas both. So how can we replace it like this?
Okay. See, this is a constant value, right? This is a given value. Summation of small xi square, it is a given value, isn't it?
Yes, sir.
So it can be taken inside the summation.
Okay, sir. Okay.
Isn't it?
Yes, sir. Okay, sir. Got it.
Right. So we are writing beta hat as summation of small ki into capital yi, where we are seeing that beta hat is a linear function of capital yi. And then again we are replacing capital yi with alpha plus beta xi plus ui. And then subsequently we are getting it as beta plus summation of ki ui. Because we know already we have done that summation of ki is equal to 0 and summation of ki capital xi as 1. Now if I take mathematical expectation of both the sides, then we are getting expectation of beta as expectation of this. Now this doesn't have any expectation, it will come out of expectation. It is a given value, and then we are having like this. Now why is out of expectation? We have already discussed that this is non-stochastic. And we know expectation of ui is equal to 0 by assumption. So essentially we are getting this part as 0. That means expectation of beta hat is equal to beta. And this means that beta hat is an unbiased estimator of beta. So the first line Here we are showing that beta hat is a linear function of yi. Here we are showing that beta hat is an unbiased estimator of beta. Then we need to go for proving that beta hat is an efficient estimator of beta. Now, as I said, an estimator would be efficient provided it has the minimum variance vis-a-vis all the unbiased estimators. So suppose there are several unbiased estimators of beta. If beta hat has the minimum variance among all these unbiased estimators, then I'll say beta hat is the efficient estimator of beta. And for this, what we are doing? We are considering another estimator of beta, say beta star. We are considering another estimator of beta, say beta star, which is equal to say summation of wi capital yi. Just see, for beta hat, we were getting summation of ki into capital yi. So beta hat was summation of ki into capital Y. We are defining another estimator of beta, beta star, as summation of wi into capital yi. Now, let us assume that this is an unbiased estimator. That means beta expectation of beta star is equal to beta. Now, if I just replace this yi here, then I'm basically getting an expression like this. Now, if beta star is an unbiased estimator of beta, that means expectation of beta star is equal to beta, then and summation of wi capital Xi, that is equal to 1. If these two are not true, then we will not get it as unbiased estimator. So by assuming expectation of beta star is equal to beta, we are basically deriving these two conditions. That summation of wi is equal to 0 and summation of wi capital Xi as 1. So essentially what we are getting, beta star h, beta plus summation of wi ui, and in the process expectation of beta star as beta. So first we are assuming beta star to be an unbiased estimator of beta, then subsequently we are getting these two conditions. Now, what would be variance of beta star? You know, variance of beta star is nothing but expectation of beta star minus expectation of beta star whole square. Again, expectation of beta star is equal to beta. So we are getting variance of beta star as expectation of beta star minus beta whole square. And from here, you will get expectation of beta star minus beta as summation of wi ui. So we can write this as this. Now, let us just go for decomposition of this. We can write it as expectation of summation of wi ui square plus 2 into summation of wi wj into ui uj. You know very well this formula. I mean, basically a plus b plus c plus d all whole square. So we are getting an expression like this. Now, if we take the operator of mathematical expectation inside the summation, then we'll get summation of wi expectation of ui square plus 2 into summation of wi wj into expectation of ui uj. And we know that by assumption and I'll have sigma square into summation square, because this is nothing but sigma square. I'm getting as sigma square wi square. Now this wi square, this can be rewritten as, say, wi minus ki plus ki whole square, then summation sigma square, as it is here. So basically this wi square, I am just rewriting that in this fashion. That is wi minus ki plus ki whole square. Then again a square plus b square plus 2ab along with the summation operator, and then whole multiplied by sigma square. Then what is happening? I am getting this, okay, plus this. What is this? Ki. And we had assumed that ki is equal to xi by summation of xi square. Xi means small xi here. So what I am doing, just you see, I am just replacing the value of ki. Okay, in the entire expression except the first part. You can replace that all there also, but not required because we are not going to do anything on that part. Now from here we are getting this expression. Let us see this. When I take summation, it basically becomes summation of small xi square divided by summation of small xi square whole square. Because as I said sometime back, this is a given number. So it doesn't matter whether you take inside the summation or you take outside the summation. In the same fashion, what we are doing, just multiply this with this. So I'm getting wi xi divided by summation of xi square. Again, it is small xi. And here we are getting small xi square divided by summation of small xi square whole square. And then you take the summation of so one small xi square xi divided by minus cancel out. So
Sir,
I
your
have
voice is breaking a lot. Sir, your
this
voice.
as one.
Sir,
I have this will also be equal to this recording because of network issue.